So I kind of want to go through a little bit of an example. I really like this example that was in my textbook. So a hammer thrower in some athletic competition, he's taking a hammer and it's attached to a chain, and he's swinging it around his head like a helicopter kind of motion, and then tossing it or something like that. But we just want to know about the actions that are, or the forces that are taking place when he is swinging that hammer in a helicopter shape or whatever. And so we're given effectively how fast he swings this hammer, because we're given, well, he does this many rotations in 5.2 seconds. So if we can grab this equation up here, which equation do I want? Oh, there isn't really a nice equation. Basically, 7.5 times around in a circle. We were talking about how when we're talking about circles, we're talking about some proportion of a perimeter around a circle. Well, 7.5 times that proportion, and you know that proportion is 2 pi. Does that make sense? So you're going 7.5 times 2 pi time radians in a certain amount of time.
So would 7.5 be the frequency or no?
No. It's trying to give, let's see, it's an equivalent of trying to say a car is going, travels 70 kilometers in 3.5 hours. So you're given some distance, and in our case, that distance is the number of times in the circle, and then the time that it takes to go that distance, right? And so we don't need to know how long the chain is. Instead, we skip that part and we say, okay, well, we know how many angles he goes around, or what the angle is, because there's 7.5 times 2.5 radians in that distance. So our angle is 15 pi radians. And then the time that he gives is 5.2 seconds. And so we can calculate this out and we get 9.06, what could be written as radians per second. I chose to write it as per second here. Does that make sense for now? I think so.
Yeah.
Just this part. Okay. So now that we have some starting point, we have some angular speed. Now we're given how long the chain is, or what the radius of the circle is. So we have radius, we have angular speed, and we have our mass. So there's many different ways. F is equal to ma. We're trying to find the force, right? But it's actually not so explicit, because it says find the average tension in the chain. And I suppose you just need to have a understanding that tension is a force. Does that make sense? So you're trying to find the force. F equals ma. We got a few different ways to write acceleration, But because we didn't find the speed, we could find the speed if we really, really wanted. But we were asked to find the angular speed, so we had the angular speed. And we have the radius. So we can take this equation for acceleration and plug it into F equals ma. And we get this equation for force. Mass times angular acceleration squared times our radius. We know all of these numbers. And thankfully, all of these numbers were given in SI units. So I just plug in everything in SI units and then calculate the force afterwards. Does that make sense?
Yeah.
I don't think that they'll give all the different kinds of force